A sinusoidal carrier wave has a constant amplitude and the frequency of 1.2 megahertz. The carrier wave is modulated by a signal wave such that 1 volts of displacement of the signal wave causes a change in frequency of 25 kilohertz. Now, the important point over here is this statement that it has a constant amplitude and a frequency of 1.2 megahertz. The signal wave has frequency 8 kilohertz and the amplitude of 2 volts. State the name of this type of modulation of the carrier wave. Now we know if the amplitude remains constant, the modulation is a frequency modulation. So the answer, the name of this type of modulation is the frequency modulation. We know that the other one is the amplitude modulation, but in there the amplitude does not remain constant, and in this statement we were specified that we have a constant amplitude, and hence the type of modulation is a frequency modulation. Now, for this modulated carrier wave, determine the variation, if any, in its amplitude. Now, they mentioned that it has a constant amplitude, right? If for frequency modulation, the amplitude remains constant. So the change or variation, this means change. Change in amplitude would be 0. What about its frequency? Well, frequency would vary by, we have 25 kilohertz. So the frequency, which is 1.2 megahertz, varies. Now it will vary in plus minus 50 kilohertz, right, on both the directions. So if the change is 25 kilohertz, then it will displace in both the directions because it has to oscillate in both directions. So it will vary by plus minus 50 kilohertz. An audio signal is transmitted by the means of modulated radio wave. The variation with frequency of the amplitude of the radio wave is shown in this figure. So here we have frequency, here we have the amplitude, and the graph shows the radio wave in this way. So we can see that for this transmission, we are required to determine the wavelength in kilometers of the carrier wave. Now, the wave is a communication wave, right? So it travels at the speed of light. So by communication, what I actually mean is it's a radio wave, and radio wave is an electromagnetic wave, right? So we know that the speed of the electromagnetic waves is speed of light, 3.0 into 10 raised to power 8 meters per second. And we want to find the wavelength. So the wavelength, we know that speed is related to wavelength as f lambda. Or you can rewrite this as lambda over the time period as well. So, but we have frequency over here, so we'll just use f times lambda. Now this gives me lambda as c by f. Now corresponding to the wavelength, we have the maximum amplitude, which means that this would be, the frequency read off here is 240 kilohertz. So this would be 3.0 into 10 raised to power 8 meters per second divided by 240 into 10 raised to power 3 hertz, which gives me 1250 in meters, and in kilometers this would be 1.25 kilometers divided by 1000. So this would give me 1.25. The next part says to find the bandwidth of this wave. Now remember, the bandwidth is this distance between these 2 points. So this distance is just 255 minus 225, which is 30 kilohertz. So we write 30 kilohertz. The next one states that the frequency of the audio signal. So we know that the frequency of the audio signal is this distance in this graph. This is the frequency of the audio signal, while this is the bandwidth. So that distance is 255 minus 240. So 255 minus 240, which turns out to be 15 kilohertz.